Every session, your agent wakes up with amnesia, the same mistakes, the same rediscovery, and the same wasted tokens. Memory is how we can solve this, but it can be a superpower, but not all the time. You're listening to Agentic AI in DevOps. I'm Fernando, and with me are Vladimir and Andrei from Sirob Technologies, where we build Boris, our Agentic DevOps teammate. Today, we are into agent memory, what the agent knows between sessions, how it learns, and what happens when the memory system itself becomes a security liability. So let's get to the news.
Well, that was a solid introduction, Fernando, I should say. You're getting good
getting
at
good
that.
at it, or doing my best.
So the memories. Today on the news, we have the Hermes agent, and you might ask what Hermes agent is. It's a new fad in the world of AI. And well, maybe, who knows, time will tell, but people running around with it. And if you open LinkedIn, well, less LinkedIn, more of the YouTube, then like it's kind of hard to escape. Or at least if you open my YouTube, I guess it's all personalized nowadays. If you know OpenClaw, which was released earlier, I believe this year, OpenClaw was a first of its kind self-improving agent, which was also positioned as a personal assistant. But one thing that OpenClaw didn't have when it was released was a memory. And Hermes is taking a different approach. Again, it's a self-approving agent, but now it has a memory built in, and it's able to manage it. It's well, like when I'm saying memory, it might sound presumptuous because it's actually nothing fancy that's going on there. It basically has two files. It has a memory MD where agent stores its nodes, environmental facts, conventions, things it learned, and it has a limit of approximately 800 tokens. It also has a user MD where it stores like the profile and preferences, and that one is limited to approximately 500 tokens. And all of that stored in a home directory under .hermes memories. Plus, past conversations are stored in SQLite, and it's possible to search through the full text search and LLM summarization. So there are also possibility to plug the memory, like mem0, for instance, and then you're able to argument the built-in memory, and so that will work alongside it. And it also can, like similarly to the OpenClaw, it can build its own skills and then use them. And the same as OpenClaw, it comes with different access patterns, like so Telegram, Discord, Slack, WhatsApp, and so on. And plus it has like a different terminal backend that it can use. So the general position there is that they're positioning it as like a memory, like the memory is like a centerpiece of Hermes, basically. The big thing with OpenClaw was the fact that it had this concept of gateway, so you was able to connect different communication platforms. But with Hermes, as I mentioned, they're trying to drive the memory angle in there, and that's kind of useful. That's why we're bringing up, because it's useful to our today's discussion. I think Hermes agent was released like a couple of weeks ago, like maybe a month ago. So it's not the most recent news, like not yesterday news, but it's still recent enough to qualify as news, and it's also a good bridge for the main topic of today. So I urge you to remember what kind of memories we discussed, or like when I mentioned the Hermes, and then we can identify what type of the memory that is when we move to the main topic. Do we have any other news, Fernando, for today?
Yeah, I think there's one that came out recently about cloud managed agents, right? So this was released before, so where basically you can define your agent and then Claude or Anthropic, right? They are gonna host it and run it for you. That's why they call it managed agents. So now they add memory to that. So this was about a week ago, which allows you as a developer to push custom memory to your agent, and they're building more compliance things around it, right? So imagine if you work in a regulated industry and maybe they want to use these cloud managed agents. A lot of times, because the memory, you're going to see as we discuss further, but the memory influences a lot on how the agent behaves. Sometimes it's not going to ask you again for a certain thing because in the memory, the answer is already there, which means memory needs to be managed properly. So with Claude and Anthropic, they are creating this way for you to manage that memory yourself, but then with some security mechanisms around where you can say like, hey, Fernando is the last one who pushed a memory record into the Claude managed agent memory. So all of these, I think, is going to make more sense as we go deeper into memory. But if you're looking to cloud managed agents, after today's episode, you can now understand better why this can be maybe a plus, a way to make them more useful for you.
Yeah, another thing to mention that Cloud Code itself also added the memories like somewhat recently. I think within this month they didn't have it, but now they also have like a text files. I do recommend you actually research what's inside .cloud directory in your home directory, because there are quite a lot of interesting stuff, like which is like with internals, how the harness works, and then under the projects you will be able to find memories related to the projects again as a text files. So in the Cloud Code case, like pretty much project based and project scoped.
Yeah, and you can see maybe during the sessions we mentioned before, right? Things like the dreaming feature, or now I see a recap thing that shows up as I'm using it as well. So all of these are related in a way to what we are going to be talking today, right? So maybe it gives you a bit more context in case you're using Cloud Code and you see those things and you're like, I don't understand exactly how they work. We hope that today's session is going to help shed some light into that, so you can better understand it, right?
I think that the recap is more like the UX rather than the memory itself. It just writes a summary. Like if you loved the terminal for a long time, it just writes a summary of the session. So when you come back, you can remember what it was about. So it's like less the memory. It's like more a reminder for you as like a UX
for the user,
thingy.
Right?
Yeah, but it's I do appreciate this feature, like jumping between terminals, or leaving the laptop for the night, coming back in the morning.
Yeah, you're like, what was in this session again, right? I have 8 tabs.
Yes, exactly, and that's kind of a summary. I think that's great. I like that.
Yeah.
Good job on that, Anthropic. But let's dig into the memories itself, like the main topic. Oh, actually, nice. I think Vladimir wanted to mention before we jump. Vladimir wanted to mention that the Anthropic platform is available on the Bedrock, or Bedrock is available on Anthropic platform or something.
There's some partnership there. What was up, Vlad?
Maybe the key point is like as you don't need to have Anthropic account to use Anthropic models, which is maybe interesting for some of people who don't want to create extra accounts. So, and AWS become more, like I said, open router, the routing thing where you can get the different providers from one central point and also from the central billing. Because I know for a bit bigger organizations, it's maybe a problem to understand, like, is who exactly using what now, why we are now using Anthropic or Codex or whatever. It is in one place. If they already use AWS, they can get everything in place. I think maybe Ogre's Cloud will just provide the same thing, just to make it a bit simpler for the builders. Because you don't need to go somewhere, create extra APIs, rotate it.
It depends how much other clouds have money and how much those clouds are willing to give Anthropic, because AWS did a huge investment in Anthropic and committed compute. So this is how they got that feature. They basically paid for it in cash. OpenAI, like there was the same deal AWS with OpenAI just a couple of weeks ago announced, where actually it was in February, but basically the AWS announced a big investment round into OpenAI, and a month later AWS says, well, now we might have something from OpenAI there, like on the Bedrock, which is which might be coming. So I would watch that space, because like if there is investment happening, usually the company that makes an investment gets something out of it. So AWS invested in Anthropic, they got this. We actually haven't yet seen what exactly AWS is going to get from OpenAI. So we haven't seen like into OpenAI with Bedrock, but maybe there will be something like that coming. So watch that space.
Yeah, one thing to notice, when I was seeing people discussing about these deals, just to be aware of, I think there are always this idea that if you use Bedrock as a way to access the models, your data stays within AWS, right? And the whole VPC thing stays there. If you use this Anthropic platform on AWS, the data still goes to Anthropic, right? So just be aware of that you are not keeping the data within AWS. It's just basically a gateway to get to Anthropic through a different billing process, let's say. So this is just important for compliance, right? So it's not a replacement of Bedrock.
It's just super confusing.
Yeah, so just be aware of that.
It's have a reason. It's basically allow builders to move from Anthropic to AWS. Like, as you make a small step, use it as it is, like a lift and shift, and maybe after move to like a Bedrock APIs and so shifting. It's similar to like as a Kafka or OpenSearch or whatever. You just lift and shift to AWS and then move to something, whatever fancy.
And you refactor and
it's
just a good note there, right? To be aware. Nice. Yeah, so that's a good one, right? So I mean, in a way, they try to make it easier, right? I think billing and procurement is always a pain, and I have talked to a lot of engineers working teams that deal with regulated industries, and it's still a bit of a hassle to use these more modern coding agents. Most of them are still on GitHub Copilot because Microsoft has all the deals and all the NDAs in place and this kind of things. But I don't know for you guys, not the topic for this session, but I haven't used Copilot in a while. I still feel this kind of like a 1 year behind tool, but I might be like just biased because I don't use it and I don't hear anyone talking about it. To say this might be.
I spoke to the person yesterday, and he said that it's like it was 1 year ago. And also Amazon recently announced that they're cutting off subscriptions for Copilot, so you will be paying API rates for Copilot and in a GitHub. Yes. So listen our previous episode about AI Big Squeeze. It's coming from all directions.
Yeah. The benefits of Copilot is you don't need to integrate it. It just exists. If you're using GitHub, you click that button and everything is done. It was quite cool in the past when other tools was a bit lagging and you can't integrate them easy to GitHub. But now you can integrate everything to GitHub. It's same one click, doesn't matter. But
So maybe this is a step towards making it a little bit easier to use more modern tools like Codex or Cloud Code or the other ones. Right? Cool. Just watch out for that.
So,
yes, agent memory.
Main topic.
So maybe for a quick intro, I think when we discussed this in the previous episodes, we were like, memory, besides being a very important topic in general, for us three in particular, memory is a big deal on what we do with Boris, right? So since we mentioned briefly in the beginning, like of the episode, we built a DevOps agentic teammate, basically, right? And memories plays a big role there to make sure that it is effective as it is. And that was where like, oh, we need to discuss with everyone so they understand how memory works, and then we can touch a little bit more towards the end on some strategies that we took there, so you hear from practice, right, and not just the theory. Do you want to? I can give the quick definition, but like, and then we can split. We have some key concepts we want to share, but from a definition perspective, you can just think, if you start a coding session with the coding agent, whatever it might be, by default, they are always stateless, right? So if you would start a session now, imagine like someone onboarded your team. You sit with the person, you teach them like, hey, here's how we deploy things, here's where the code is. You spend a whole day working with them, and you're like, cool, great. You go home, next morning, they come to you, hey, I don't remember anything. Where is the code again? Where is the thing? And then again, you need to explain everything, right? So if you don't have memory for an agent, basically it's that colleague that doesn't remember anything, and every single day you need to explain the same thing over and over. So memory is a way for you to basically capture parts of the conversation that you're having in every session, so that in the next session, the agent can remember things, right? So think about it like moving information between sessions. This can be decisions you made, the tools we use, preferences, like all of these things. So that's how you can turn these agents into actually like a teammate that understands your context and is not just a generic LLM, right, that knows what was on the internet. I don't know if you guys have something to add to the definition. Yeah.
Sorry, I'm lagging behind a little bit here on a bad connection. So one thing that we discussed in the previous episodes was skills, right? And skills is a form of procedural memory. So there are like types of memory, what kind of memory it is. So like the procedural memory is a type of the memory. There are 4 of them. If you define them via Koala framework, we will have all the links to the research in the show notes. But you can also look at the memories. You can classify them based on their source. So, for instance, procedural memory, skills. It could be something that you wrote for the agent and you explain for the agent. Basically, you prepared a snippet of text that explains some concept. And then, as if you remember our previous episode, agent will be able to load that dynamically into the context and refer to this. That's kind of a lot of memories work this way, so that we'll have a retrieval mechanism that will load to the memory, to the context. So it's important because this is a curated memory, right? So you created it, you wrote it, and the content of that memory is trustworthy. It's something that agent can rely on. There is a different type of memory, like for instance, when we spoke about Hermes, right? You might have like episodic memory, you can have semantic memory. So if you look from the source of that memory, there will be memory generated by the agent. Like for instance, if you voice your preferences, if you correct the agent, if it has a memory capability, it will be able to go through your chat and then pick those snippets of information that's useful and could be potentially used later, and then we'll store it. And that is a blessing and a liability at the same time. I think, like in the pre-show, Vladimir had a good example of when you browse the web, like you Google search something, and then you start to see ads all over the place about what you Googled, like if it was a product.
We all love that, right?
It is kind of the same. Yeah. So like with the memories that, and also another thing, important thing, like note that Hermes, like when I spoke about Hermes, but it's kind of the same for Cloud Code, for instance. It's the same for the Boris. You need to limit memory volume for it to be useful, and you need to manage it. So you will have, like when agent works, you first capture memory, but then you need to have a procedure to manage it and maybe remove irrelevant memory, maybe summarize. There are a few approaches that you can do. Like basically you need to teach agent to forget because if it just keeps remembering, eventually it becomes just too much, and it's really hard for the agent to pull the relevant information out of that corpus of data. So you have a few stages here, right? So you have the actual remembering part. How do you capture that? Then you have a management of it, like auto dream, like in Cloud Code. If you've seen that feature, that it's called different ways in other agents, but basically similar to how it happens with humans when we sleep. We compact what happened to us during the day and we generate the memories out of it. But maybe we forget traumatic experiences. The same here with the agent, and then you need to have a retrieval way to retrieve it and identify the useful memory, because remember, the context is limited, so you need to find a way to load the relevant memory, not something that will actually divert agent from what it's doing. So that's why I'm saying it might be a liability. So if you manage to poison your memory somehow, that will come back and will continuously bite you until it's forgotten, assuming you have a memory management feature.
Yeah, I think like for me, this whole memory thing, and you see with Auto Dream that Andre was talking about, that it's very similar to how humans. I think we are trying basically to copy the way we would do it a person, right? So if you think about the procedural memory, for me, it comes is like with a colleague. Let's take that analogy of the new colleague, right? The junior engineer. It's like the manual, right? Like we have here a run book on how we do things. So it's a procedure that person, in the case that agent, is going to go through those rules and execute the procedure, right? And then as they are executing things, they start writing their own notes. And then that becomes kind of a semantic thing where next time when they want to do something, they're like, oh, I have notes about how this happened maybe yesterday. And then there is more like closer ones, the kind of episodic memories, where in a way it could be like, hey, today I ran, I don't know, Terraform plan. This is what happened. There was a drift. And then next time when I'm going to run Terraform plan again, I remember that, oh, last time there was a drift, right? So it's kind of a short memory thing that you can still use it there to understand about particular episodes, particular actions. And as a person, you would keep that in your brain, which then goes to the last memory, which is basically in context, right? So which is what you hold in your brain during the day as you're working. Or in that case, this junior engineer, right? So imagine that then I think connects well with this context thing, that if you give them, hey, here is a run book of 200 pages, and now execute 10 tasks today, like the brain of that person by the end of the day is exploding and they cannot work properly anymore, right? So the same happens to the agent. So memory is something with the retrieval, like Andre was saying, you need to be smart on how you retrieve, because if you start a session and you load the context full with all the memory that you have, that's it. There is no head space for the agent to work anymore, right? And the auto dream is basically the same idea indeed. When you go to dream, then you create this long-term memory. So your brain shrink what happened today and put it somewhere in the back of your head, let's say. And this is basically, again, Cloud Code generating like some files that's going to go into this, let's say, long-term memory more on the semantic side. So these analogies might help you understand the different phases and when to use each, right? So if you have a procedure, like for example, with Boris, there is SOPs, right? So there are things that we know, this is how we want, for example, to create a post-mortem after something happens. So this, we don't need to keep explaining every time. We create a procedural description, we give it to the agent, and next time it knows how to execute that, right? So you can use kind of, if this would be a junior engineer in my team, how would I teach him or her to do this thing? Would I let them learn by experience, by going through and executing the task and creating their own notes? Would I create a procedure, a run book? Or is just something that's needed during this session and we don't need to keep the whole thing, like during this work day, once they go home, it's fine. Like tomorrow, they're going to pick up from what we have, right? So maybe just a way to kind of connect all of this technical stuff with day-to-day things to make it easier to remember.
Right. Like if we take another potential example is we have in Boris like AWS health notifications. and some of them could be super duper annoying. Like, for instance, AWS notifying you that it's gonna retire your ECS Fargate task and replace it. Yeah, like I can see, like if you have a super fragile workload that doesn't tolerate any kind of restart, that might be useful. But in most cases, we are running multiple instances of the workloads, and like killing one while the another task is running, it's not a big deal. So then, like, for instance, you can tell Boris, like, Boris, remember, I don't care about this. And next time, when it gets AWS health notification, it actually uses the memory to see if we have any preferences, and it will skip it. Or you might have a certain feature configured in a particular way that is different from the way AWS recommends you. If you ever did AWS certification, like if you presented with the question on a certification, like, and you don't know what to choose, you choose the question, you choose the answer that makes most money for AWS, and you won't be wrong, like in 80% of the cases. And like that's like how certification works. Like in AWS wants you to build in a certain way, but a lot of those approaches that they recommend, they might not be as economically efficient as they could be. Or you might have some other limitations that doesn't allow you to configure it in a particular way. It doesn't depend on you. And then like it's useful to use memory to say to the agent, like, look, we do it this way because of that. Next time you encounter it, please, pretty please, don't tell me how I should use it, because this is how it's supposed to be in our environment. And because otherwise, if you don't have it, each time it will, tell you like you're using it wrong, like fix it. And you're like, no, I'm using it how I wanted to use it. So that's like where memory comes in very, very handy. But again, it could be a liability if, imagine, you have changed the way you've been doing it, then your agent still thinks in an old way. So you need to find a way to manage it somehow. So this is like where the semantic memory becomes a liability. So I would say procedural memory is great, because especially if that procedural memory is generated by you. Because like Hermes and OpenCloud, they can generate their own skills, so like marketplaces for their skills that they can exchange, and they can pool the skills on themselves. So you don't control those as much. But like the ones that the memory that you control, I think like we should have a more control and more visibility into the memory, and being able to adjust it. So because if you're building the chatbot, like just a chatbot, your virtual girlfriend or boyfriend, whatever, then having that semantic memory is okay, and it's useful because the bot will remember conversation across chats. But if you're building something that you rely on to do the work, having semantic memory, in my personal opinion, I might be wrong, and I'm ready to receive the tomatoes thrown at me. It actually makes already non-deterministic LLM even less deterministic, because like when you have the agent without memory, at least you can assume clearly and with confidence that it have no idea. And then if you're just giving it like some context, it's manageable to know the starting state. And you can manage that. You can predict what's going to happen.
Yeah, I think with that, what I saw, I came across this happening a lot as a project evolves, right? Like you change the technology, change an approach, and then the model keeps trying to do the same thing. With the basic things like using plan mode before that already help you visualize this, right? So when you see in the plan that you're like, hey, this is actually, you're taking the wrong approach here. Cool thing is that you can tell the agent to fix its own memory, especially if it's files, right? If it is something like a RAG system where then it's more complicated. But if you think about a coding agent where everything is marked down, then it's okay. You can say like, hey, update your memory, go there, fix this file. We don't do this anymore. We do it like that. This, I think, is a similar thing. Like it's maybe like if you use ChatGPT or like the chatbot kind of thing. I have felt this multiple times where suddenly every single chat you ask something, it tries to correlate to, oh yeah, because you talked about something in a single chat, now it thinks this is what you want to talk. So it always tries to correlate chat so that memory gets poisoned basically, and then they start to become less useful because they don't give you a more like a raw answer anymore. It's always like trying to, but you can also manage that memory, at least with Claude, right? You can go there and you can change the memory to keep it up to date. So it indeed is a bit of a thing that requires, which is the second part, right? Like there is a workflow to this, basically a life cycle to a memory. Like first you need to write it, right? So this is going to be indeed procedurals, skills, or just markdown file that you're going to use, could be the Claude MD. Then you need to manage it basically, right? Which is the second part. Like how do you make sure that that is still up to date so the agent doesn't go doing like wrong stuff? And then is what Andre is saying, indeed, you can start getting like, oh, shoot, yeah, it's doing like this because, I don't know, like I have this written somewhere in another file. And then there is a whole retrieval part, which is where you need to be smart on what do you actually load and when. So, and also that when you load, certain kinds of memory are trusted implicitly, right? So for example, we discussed before, things like Claude MD or the skills like these, if you take them as procedural memory, as soon as like Claude MD is loaded automatically, right? And trusted. So if you use that, so also be careful with the security aspect of memory, not just like doing the wrong thing, but if there is an injection in that procedure about doing something specific, your agent will trust it, right? Because it's like a memory. Let's imagine as a human, if you have memory of a certain thing, you're going to believe that to be true, right? Because it's a memory in your brain. So this is just one side note that besides the whole, like maybe it might do things not the way you want anymore, is also can be also a security vector, right? Like, so you need to be aware of that as well. So it's just more than overloading a context, is also what is in there, right?
Yeah.
Cool.
Could be a good thing, could be a bad thing. Yes, let's wrap it up. It's been 30 minutes. Thanks everyone for tuning in. Next time, I think this was like the final episode of our foundation series, because we did cover all of the foundations now. And as you can see, we are building up one episode on top of another, and we can have a conversation now about those concepts that go a little bit deeper. And next time we should start to dive into the actual applications, like where do we apply the agentic systems in a DevOps. You've been probably waiting for that for a long time, because the podcast called Agentic AI and DevOps, and we're just talking about harness engineering. But it's kind of hard without the context and the whole field being new to discuss the applications without having those foundations. So we're making sure that we have you on board when we start those discussions.
Indeed. So cool. Thank you, for joining today. We hope you now understand better how agent memory works, and we'll see you in the next one.
Bye-bye.
Bye.